Go ahead. All right. Hello. Hey, guys. How was the first day? OK. So today, it's still about Vue.js, but we're going to switch gears a little bit and talk about single-page applications. So can I see a show of hands how many of you have built or like at least know what single-page application is? Great. So as far as I know, Taylor has never done it before. This talk, I basically assume that we need to start from the ground up, kind of explain the reasoning behind it, because Laravel itself, you're probably accustomed to doing a lot of view rendering on the server side, and accustomed to the mindset that each URL basically corresponds to a new request to the server and sending the page back. But single-page applications, what is it anyway? So quick Google leads you to the Wikipedia page, of course, which tells you this blah, blah, blah. It's a website that fits on a single web page with the goal of providing a more, it doesn't really say a lot. But to paraphrase a little bit, first, single-page application, of course, it's loaded on a single page, right? And the second most important thing is there is no page reload on UI navigation. So imagine when you're going from a URL like /home going to /post1. Usually you would see a full page reload. You send a new request to the server. You fetch the corresponding data on the server side, and then you feed it into a Blade template, right? You directly render the whole HTML and send it back. So that's how you would do it in a typical back-end powered application. But for single-page applications, there's no page reload. So what we do is we just dynamically fetch data over AJAX. We don't request a new page. We don't reload anything. We only request what's changed, which is the data, right? So once we get the data, we will dynamically render the view on the client side. And to do that, it basically entails that we are already sending the front-end templates as part of our front-end application to the client on the initial request. So, which means because we are only fetching data over a single AJAX request, it's going to be really fast, right? And the UI updates will feel really snappy. So the reason why you would want to use an SPA is that especially for applications with very complex UI requirements, it will result in a more fluid and snappy UX because you don't have to wait for the page to reload, potentially requesting new resources, and you're less constrained by the round-trip latency between the client and the server, and you don't have to re-evaluate all the JavaScript, CSS, do the layout, and re-render the whole page. So you get the point. And another more important benefits of single-page applications is that it leads to a more decoupled architecture. So in a traditional backend focused app, right, if your application is largely very static pages with little bit of interactivity needed, you probably don't need to care that much. But imagine you are building a dashboard-like app, or you're building, say, a mail client like Gmail, right? It doesn't make sense to reload the page when you navigate from the main inbox view to a single mail view, right? Although you would naturally want the URL to change because let's say you're at /inbox and you click on one email title, and you should render that email's body, but you also want the URL to change to like /inbox mail ID equals blah, blah, blah. So this is only feasible if you're building it as a single-page application. And when you do that, you get a more decoupled architecture because now you have essentially two very decoupled code bases. The front-end code base is focused on untangling the UI complexity. It focuses on client-side state. It focuses on what components, what layout, what UI I should be rendering. And you can basically, you will be able to divide the code base into so cleanly that you can have one guy working on the front end and one guy working on the back end, and then the collaboration between the two will become very natural. And the back end can be focused on data logic and exposing API endpoints. And the benefits of that is that because all your backend routes are essentially API endpoints, they can actually be reused for other types of clients. Imagine you built a web app, and later on you want to add say, a hybrid mobile client to it. Or you want to add a native like iOS or Android client to it. You can basically directly reuse all the API endpoints you've built because that's what you've been focused on the back end. On the contrary, if you didn't have that plan in the first place, and then you have, you have all these data fetching logic directly inside like a view controller on your back end, then it becomes a headache to then refactor and decouple these data fetching logic from your static view rendering logic. So this is just some of the benefits. That's why you want to consider it an SPA. But probably more important is that not every app should be an SPA. So I'm not saying that SPA is, definitely superior in every scenario. It is important to carefully consider the trade-offs before you jump in. If you feel that your application does not justify the extra effort to build an SPA, then you probably should not do it. But it's still worth giving it a try. So, of course, it's not that easy to build a great SPA because it comes with its own challenges. And the first challenge is that you want to display semantic URLs without reloading the page, as I said. So how do we do that, right? Like, if you navigate to a URL, shouldn't the browser just, request a new page from the server? Also, you want to dynamically render correct UI based on URL navigations. A typical example of this is that imagine when you're writing templates, you would have like a layout file, right? You would have a header, a sidebar, content, and then you would probably like yield or render the body of the thing inside that layout. So you would have some similar concepts on the client as well. For example, if you're building an email client, again, the main Chrome of the application will stay the same. And when you go from like the main inbox view into a single mail view, only that a part of the UI has changed, but the outer parts, containing parts, will stay the same. So, but the URL has changed. So there is a natural mapping between the URL and the UI layout structure in your application. And how to declaratively create that mapping is also an interesting problem. And finally, deep linking and SEO. These are relatively hard problems, right? Deep linking is actually naturally solved if you solve number 2, because if you are able to render arbitrary correct UI layouts based on URLs, then you can just do that on the initial render. So deep linking is kind of solved by number 2. And SEO has been probably one of the biggest problems with SPAs. And luckily, Google has basically been updating their crawling technologies, and their crawlers are now smart enough to index single-page applications correctly in most cases. It's not still 100% reliable, but they're doing pretty good. I've had a friend personally testing it. He built a full SPA blog system, and Google has been correctly indexing all the posts he posted on his personal blog. But still, SEO is one piece of the puzzle, because on the other hand, there's also like the initial loading problems, which are combinedly can be solved via server-side rendering. But server-side rendering is a very complex topic in its own, so I'm going to leave that out for this talk. Okay, so dealing with the first problem that we just talked about, displaying correct URLs without reloading the page. So there is an API for that, and it's part of the HTML5 history API. If you just Google that, you'll probably see what it does. But essentially, So previously, the window.history object in the browser gives you the method to sort of navigate in your navigation history. For example, you navigated from URL A to URL B, and you call window.history.back. It's the equivalent of clicking the back button, right? So when we are building an SPA, when we navigate inside our application without reloading the page, we want to preserve that behavior. We want to be able to say, I navigated to another URL, UI updated. I click back. The page should not reload. It should also revert to the previous URL and render correct UI. So HTML5 History API gives us the opportunity to do that because it allows us to artificially push an entry into the browser's history stack using the window.history.pushState API. So we're going to see how that works just in a little bit. And now it's time to introduce View Router. So View Router is designed to basically handle some of, if not all, the problems that we mentioned just now for single-page applications. So it's a router, right? So it handles routing on your client side, maps URLs to not to controllers, but to component hierarchies, if that makes sense. So it basically does two jobs. First, it is handle the URLs using HTML5 History API. For example, if you say router.go/post1, it basically, instead of reloading the page, it'll use the push-state API to update the URL, and then it'll let the associated view instance know, hey, the route has changed, and now you should render this layout instead of that one. So imagine we have an app, and you go to /app, and the router will know that I should render these two components. I should render the root app component, and inside that app component, there will be a router view, which is similar to an outlet or a yield point in template terms. So that's where the nested component should show up. So because we're directly navigating to like the root of app, so we can define like a default component to render, which is going to be home. But let's say the user navigates inside the application to app/post1. Now, the state of the route has changed. So the application knows now, instead of rendering home inside the router view, I should be rendering the post component. And the post component, you can define a dynamic segments, just like you're doing URL matching in server-side frameworks, and say if we make that the part after post a dynamic segment, it becomes a param for the route, and the post will be rendered with a params, knowing that ID corresponds to 1. So this is like a high-level view of what actually happens when you use a router like that and you navigate between pages. So let's do some demos, and hopefully it works. OK. So in case you didn't know, we have something called View CLI. And what I did just now is just npm install gViewCLI. Because I don't have internet right now, I'm just going to not really do that. So install VCLI. Now I have the view command. And if I do view init, so followed by a template name, that will basically scaffold an application with some recommended build setup for single-page applications. So this is the template that I'm currently using, which is Webpack Simple 2.0. It comes with a bunch of stuff, like Webpack, obviously. And it uses Vue 2.0. And it comes with hot reloading and other fancy stuff out of the box. And more importantly, the development server that comes with this template does one important thing that is required if you want to use the HTML5 push history API with correct deep linking. Because let's imagine you have an app that renders at app. Let's go back to the example here. And now you navigate to this. Because we're using the push state API, there's no page reload, and we are rendering the correct content. What if the user directly visits this URL? They share it with someone else and directly visit it, right? By default, your server will try to actually match this route, and it will not find anything. And it will tell the user, this is a 404, right? So what you need to do on the server when you're building an application like this is that you want to essentially make sure any URL that starts with this is returning the same HTML page. Right? So you need to do some route configurations on the server side to make this work properly. But that's relatively simple, because all you need to do is have a fallback or catch-all route, catch-out handler that makes sure anything that starts with this, if it's not a static asset or something, it should actually return the HTML page. And that page is where your single-page application lives. So now when the user directly requests this, they still get the same page. But the client-side router, when it boots up, it notices that the initial URL is this. So it directly renders this layout instead of starting from this and then transition to this. So this is how we handle deep linking inside single-page applications. This also ensures that the search engine is able to index and crawl and index these pages correctly, because when it directly crawls this page, it'll see this, and so it knows that this is the content it should index. All right, so back to the Vue CLI thing. So once you init the template, you will get a folder locally, and when you go into that, all you need to do is do npm install to install all the front-end dependencies. Once you're done, you're just going to do npm run dev. Hope it works. OK. So it starts a development server with hot reload at localhost 8080. So let's go there. Great. So as you can see, this is working correctly. And let me just open up my editor and, whoops. Make it bigger. This is a bit, OK. Can you see this clearly? OK, so wait, this is webpack config, which you don't need to worry about. All you need to look at is the source folder. And you can see this is the main.js. Currently, we don't have Vue router in here. So this is Vue. We're using the single file Vue components. This template already configures that for you. So the Vue file, and this is just mounting a root instance, which you don't really need to worry about. And in the app, we can see that we have the template, we have the script, we have the style. So in case you've never used a single file component before, the Vue file encapsulates the three pieces of your component in the same file. It handles template, it handles JavaScript, and handles the body. So the cool thing about this is we also have hot reloading with Webpack. So let's see the page here. And if I edit it, I can edit this to hello Laracon. So you see the update. Notice that the page did not reload. This is hot reloading, which means it preserves the current application state. Let's say if you're building a complex single-page application, and you navigate to A, B, C, and after you've done a number of interactions, now you're focusing on working on a deeply nested piece of component inside your application, right? Now, the default experience is once you edit that, you have to refresh the whole page, and then you need to do the same interaction again to invoke that component and to confirm that it works correctly. What would be better is if the application just stays the same, but only update the component that has changed. So that's exactly what hot reloading does. Because just to demonstrate what that really means. We'll use the Vue dev tools to send it to the console so that we have VM. Oh, let me refresh the page. Okay, so VM.message is hello Laracon. And let me change it to changed. Okay, so the page has changed. So if now I edit the template, you would imagine that the whole thing would re-render and it would reset to the original data. But it doesn't. So the temporary state in your application is preserved during hot reloads. If you edit the template or edit the CSS, the current state is always preserved. And changes are reflected instantly, almost instantly, like in 100 milliseconds. You don't need to manually refresh. You don't need to re-navigate to the correct position to confirm that the same component works the same way. It just stays there, and it'll just reflect the changes. So this is just kind of showing off some features of the single file components. But now let's get into Vue router. And let me just make sure it works. Okay, so what we can do is just import Vue router from Vue router. I've already installed Vue router in my package.json. If you look at here, I believe, yes. So it is using the latest Vue router 2.0, which works with Vue 2.0. So this template is basically using all the latest cutting edge stuff because it's using Vue 2.0 beta, it's using router 2.0 beta, it's also using Webpack 2 beta. So only try this out if you are really into trying out new things, but I'm using these here because these are the newest stuff, and I want to kind of showcase the latest stuff on stage. It's kind of risky, but hope it works. So we import the Vue router. So how do we start mapping the URLs to pages? So the first thing you need to remember doing is you need to let Vue be aware of the router because it needs to install a field like components and internal hooks in order for the application to work properly. If you are directly using the standalone build in browsers, for example, you are directly including Vue and Vue router through script tags, the installation is automatic. So you can just ignore those 3 lines. Okay? So the first thing you want to do is to create a router. Right? So const router equals new Vue router. And similar to creating a Vue instance, you need to pass it a bunch of options. All right? So the first thing you need to do is provide an array of routes, obviously. So how do you define a route? You give it an object with a path. So let's say at path/home, we want to render. So we imported the same app component. So I want to render app. Okay, so this does not change yet because this part has not changed yet. So let's comment that out. And you should see that our page goes blank because we didn't boot up a root instance. But we want to focus on this right now. So the routes, all it does is saying that when we visit the page at the root route, we want to render the app component. So, but how do we know where to render it? This is the job of the root instance because you are going to do the same thing. You're still going to, create a root instance. You're going to mount it to the app. I just want to be consistent and use mount from now on. And we're using a render function here by default because what you require from npm, this is by default the runtime only build. Remember, it doesn't doesn't support templates. But you can make it support templates by requesting view dist view. So with this, we can now write templates. So template, and let's just directly render the router view. That's it. Okay. I hope that works, but it doesn't. So it says, can our view property match the undefined? Okay. So the reason is that we did not inject the router into the root instance, because how does it know that we are using the router, right? So once you have called this line, the root instance will accept an option called router. Right? So you just pass the router instance that you created into it, and using ES6 object property shorthand, you can shorthand it to just router. So this means we're passing the router instance into the root instance, and the root instance simply renders whatever the route is currently matching. And it matches to app, so we're rendering app here. And as you can see, it works as intended. So I believe the hot reloading should work the same way. Yes, it does. Okay, great. So we've completed the first task. We have successfully been matching a route to an app. And notice that here in the URL, we have a little hash. I don't know if you can see it, but there is a hash in there, because by default, we are using the hash mode. We're using the hash part of the URL to simulate an actual URL. The reason for that is because HTML5 push state API is not supported in IE9 and below. So if your application needs to target IE9, you probably want to, you need to be aware that it will fall back to hash mode if you want to use the history mode. But the thing is, history mode still works. So you can, if you want to turn on history mode, you need to explicitly say mode history. And now when we refresh the page, as you can see, the hash is gone because now the page is under history mode. And if this page is loaded in IE9, it will automatically fall back to hash mode. So you can use history mode without worrying about it. It's just knowing that it will automatically fall back to hash mode. So now the next step is we want to maybe render something else on the page, show a like route navigation. So let's add a route. Page path, maybe post ID, something like that. Component post. So obviously we need to create the post component. Just for the sake of convenience, we're going to directly create it here instead of creating a view file for now. So the template should just say, hello, I am post. Simple enough. And let's render that. And now if I visit post 1, oops, doesn't work. Failed with a status of 404. Okay, this is because our index.html is requesting the dist using a relative URL. Here we go. So hello, I am post. Oops. And now you can see the deep linking is already working. Right? We visit this page and we directly see what should be rendered at that place. And now what we want to do is being able to navigate between the two. All right? So here we are directly rendering the router view. And as you may have imagined, we can make this root instance template a layout file so that router view becomes our outlet, and whatever is outside the router view will stay the same across all routes. So to navigate between routes, we will use a component called router link. Okay, so the router link by default, just, actually, I need to wrap in an li. So the router link by default will render into an A tag. All right, so to navigate between routes, you can use the to prop. You can say to post 1. I'm just going to say this. And let's create another route, another link, which simply says going back to home. So it just goes back to home. Okay. Oh, this should be the closing tags. Okay. So we see that, so the page is doing a full reload because we're not editing a view file. Only view files can be hot reloaded. If you edit anything else, the page just does a full reload automatically. So now we have the links and we try it out. As you can see, it successfully navigates between the two. All right, so what's better is that it preserves the browsing history with the forward and back buttons. As you can see, this is almost exact same experience as if you are navigating between real URLs, the difference being that everything is actually handled on the client side without anything done on the server. And also, it's blazingly fast because it doesn't need to do a round-tripping, requesting the server to render the page again and then send it back. Obviously, if you're reloading data on each request, you still have to wait for data to update. But what gives you, this gives us an opportunity to, for example, while you're waiting for the AJAX request to finish, you can display a loading indicator and then update the data once the AJAX request finishes. That's a much better user experience than saying user click on a URL, page goes blank, waiting for the server to respond, and then finally re-renders, right? In addition, the Vue 2.0's transition system works seamlessly with router views, which means you can have fancy animations when you're navigating between routes. You can have like the next page slide in and slide back out when you navigate away instead of a hard refresh. So these are things that's just not possible if you're doing a full backend rendered app. But it results in much better UX if you're doing it as a single page application. So to demonstrate that, let's add some fancy transitions to it. So all you need to do is just wrap the router view inside a transition component, as we just demonstrated yesterday. And we can give it a name, fade. Mode is out, in. And now you need to define the corresponding CSS for this. So we're just going to do it here, hard code it. So fade, enter active, fade leave active. We will apply a transition of opacity, ease, and fade enter, fade leave active, opacity 0. Okay, I hope this works. Yes, it works. So as you can see, this is something it's just impossible with a hard full page reload. I guess you can kind of simulate that by first fade out, then you actually reload the page and wait for the page reload on enter and you do the fading animation. But that's just a huge hack, and you still have to wait for that blank reload in between. But this is a seamless transition without a page reload. And if you're waiting for data to load, you can add a loading indicator at the top here. So just to give you an example, the Vue Router 2.0 comes with a ton of applications that are basically demonstrates most of the common problems that you would face when using a client-side router. So, for example, you can automatically match links to be active. So if I'm on a certain route, all the router links that matches that route will automatically be applied a CSS class. So you can just specify the CSS rules to style those active links. And for example, we can do data fetching. So when I go to post 1, whoops, oh yeah, the network is offline, okay. Yeah, so I have error handling in there too. If something goes wrong, you can display an error message. So, yeah, but if it works, it should display a post, obviously. And then the transitions. Transitions works on nested views too. So as you can see, we are navigating between home and the parent view. This is like the fade out in mode that we just used. And when you're navigating inside a nested router view, it can have a different transition. It slides. Also, it's possible to determine what transition to use based on what route you are navigating from and what route you're navigating to. So for example, if you're navigating from a path nested under parent back to parent, it animates in reverse. So this gives you the possibility to create almost native app-like user experience when navigating between routes. And imagine you're building a hybrid app, right? This is important in creating user experience that matches the experience of native apps while allowing you to use web technologies. And maybe you can reuse a lot of logic between your web app and your hybrid app. So, View Router is actually a very useful thing if you're building a mobile hybrid application as well. Okay, I think I'm almost out of time. So I want to quickly go into Vux. I don't think I'll have time to fully justify the reasoning behind it, given that a lot of people have expressed their confusion about this project. But on a higher level, Vux is a state management solution. I don't know how many of you have heard about Redux. Okay, so you kind of understand what a state management solution is. It's like a state it's like I don't know. I'm trying to explain it in the plainest words possible. And imagine that you have an object on your client that holds all the state, all the client-side state of your application. So instead of a component, so for example, you have a list of to-dos. Instead of holding that list of to-dos directly inside your application's data, you now move it out into a centralized place, which is called the store. So think of it as a database on your client. And to get data out of it, you use a certain mechanism to retrieve state directly from the store into your components. And in order to change anything, this is similar to how you would send a query. You would query a database, and then you want to change a database, you need to also send a mutation into the store for some change to happen. And the cool thing is that Vux store is a reactive store, which means whenever anything changes in the store, the change will be automatically reflected in your components. So we get the full reactivity. You don't need to worry about manually keeping things in sync. But the benefit is that we are moving state that's scattered across multiple components into a centralized place. So remember yesterday we talked about it's good to centralize state management. So essentially Vux is taking that idea to the next level where most components will just be dumb. In dumb, it means they don't hold their own state. Instead, what they do is declaratively declare what I need from the store. And when something happens, when a user interaction happens, what they do is expressing the intention for something to happen to the store. So the components become really dumb. They don't have any they have very little logic themselves. They mostly hold pure transient state. For example, the open-close state of a dropdown will still be inside the component, or maybe you will move that into the store as well. But the point being that application level state may be shared by multiple components, let's say in an application you want to display a list of to-dos. This list of to-dos, if you put in the to-do application we created yesterday in the root component, it seems to work, but later on, you have another page, another component, a different component, maybe nested deep down somewhere. It needs access to exactly the same piece of data. Now what you do, you cannot assume the relative positions between the components. You cannot say like parent.parent.parent.next sibling, retrieve that state, right? That's terrible. So in the past, in 1.x, a lot of you probably have used the event system to achieve that. So you would say dispatch an event to a parent, and then the parent will broadcast down some state, this kind of ping pong state passing, which also leads to a ton of complexity, which is why we decided to deprecate that system in 2.0. So now, when you hoist all that state out into a centralized place, you get access, so all the components can access the same piece of state anywhere, anytime, without worrying about what position it is inside the component hierarchy. So this also makes your component much more reusable and refactorable because you can move the component around inside a component tree without worrying about the event system failing because the relative positioning of the parent and child has changed, right? So the higher level diagram for Vux is that the state is stored in a centralized place, and components will be retrieving state from the store using a concept called getters. Or, to simplify it a bit more, you can directly import the store and just say, return them inside computed properties. Because computed properties are also reactive. When you return some state from the store inside a computed property, system knows that you are depending on the store's a certain piece of state. So when the store changes, the computed property updates and causing the component to update. So for a component to cause something to change, it cannot directly mutate the state. It needs to call an action, which is just a function. This function will be dispatching mutations. So the mutations are functions that are actually responsible for changing the state. And this might feel a bit weird in verbals, like why can't I just change the state directly? Why do I have to dispatch this thing called mutation, right? The point is mutations gives us the opportunity to clearly record and understand what is exactly going on in your application. Imagine you are directly changing a variable A from 1 to 2, right? And when you click that, there's no way for you to know what happened in the past. You just know that A is 2 now. But what happened? You don't know. How did we get here? You don't know. So by dispatching mutations, you naturally have a log of all the things that happened in your application. And by sending those logs to the dev tools, we get the opportunity to log, replay, and even time travel between these state snapshots. So explicit state mutations means inspectable mutation history and time travel debugging. So this is critical if you're building something that is really, really complex on the front end. So again, remember the trade-offs, right? Vux will likely make your code more verbose, but the cost is a trade-off in return for inspectable mutation histories and time travel debugging. It helps you to better understand how your state has changed inside the application. And also, so just to demonstrate, because we don't have time to build a real thing now, this is the to-do MVC app built on top of Vux. And when you do something, as you can see, all the mutations are being recorded. And with the Vue DevTools, the Vux tab, you can just click on it to time travel between these states to know, to inspect each snapshot, each change that happened inside the application. And you can choose to reroll a certain mutation. You can choose to commit to a certain point. You can just reset the whole thing, set your states back to 0. So this is very useful in reproducing bugs. And there is also a new feature in the Vue DevTools right now that you can export the current state of your application as a JSON file. So this is also useful in reproducing bugs because you can go to the bug state, export the state, send it to another developer. They can import it inside Vue Dev Tools, and they will be instantly sent to the location where the bug happened. So I think I'm out of time. So this is a very brief introduction to what Vuex enables. But if you really want to understand it, probably read the docs. But and as a side announcement, both Vuex and Vue Router are currently having 2.0 beta RC releases lined up right now. So Vue Router, and Vuex are all either at beta or RC stage for 2.0 release, and we'll probably soon be in RC state for all 3 pieces, and they will be out together as the official 2.0 release. Thank you.